Bill, I'm not telling you that it doesn't sound wacky. What I'm telling you, it's real. Imagine a technology that can do 600 to 700 G-forces, that can fly at 13,000 miles an hour, that it can evade radar, and that can fly through air and water and possibly space. And oh, by the way, has no obvious signs of propulsion, no wings, no control surfaces, and yet still can defy the natural effects of Earth's gravity. That's precisely what we're seeing.
What are the physics involved?
So there's 5 fundamental observables that, when put in the totality of this phenomenon, really help us appreciate why this is something that is certainly not our own technology. And so the first one is instantaneous acceleration, the ability to go from point A to point B and change directions fairly rapidly. To put that into context, the average human being can withstand about 9 G forces for a short period of time before we start experiencing negative biological consequences, redouts, blackouts, etc. To put that into contrast, an F-16, which is one of our most highly maneuverable aircraft, can perform about 17 Gs before you start having structural failure. Wings begin to snap off. The objects we're seeing are doing 300, 400, 500, 600 Gs, obviously well beyond the healthy limitations of anything to withstand. The next observable is hypersonic velocity. So let's take this pen again, and this is our airplane. Hypersonic velocities are those speeds that are described at Mach 5 or above. Now, we do have aircraft that can do that, and we have some missiles and some technology. The space shuttle, for example, to get to escape velocity would have to go much faster than that. The SR-71 can, let's say, at 3,200 miles an hour, if it wanted to make a left-hand turn, would take about half the state of Ohio to do it. And yet the things we're seeing are doing not 3,200 miles an hour, but 8, 9, 10, 11,000 miles an hour in our low atmosphere and able to do these crazy right angle turns. So that's something pretty obviously.
And you saw this.
Yes.
You witnessed this, and that's how you're able to calculate the speeds and maneuverabilities, is because you saw things move that fast.
Well, we calculated through also additional information. So it wasn't just seeing is believing. It's through radar data. There is historical radar data that we have that goes many decades, where these things have been clocked doing 13, 14, 15,000 miles an hour, and not just by one radar, multiple radars. The third observable is a bit of an oxymoron, but it's low observability. Now, to put that into perspective, we spend billions of dollars on a single B-2 bomber, just so it's a little bit harder to see on radar. And you can still see it with the naked eye pretty easily. Yet, what we're seeing here are things where the pilots that are trained observers are saying, Lou, I saw it, but I don't know how to describe it because it didn't look like anything we had. It doesn't have wings, doesn't have cockpits, rivets, tails, ailerons, elevators, none of that. And yet there it is. The fourth observable is something we call transmedium travel, which is now only being discussed, but it's been one of the observables for a while. So let's take our analogy. Here's our plane again. A plane looks like a plane because it has to fly. So you have a nose, you have a tail, you have a rudder, you have elevators and ailerons, and you have a jet engine. And yet a rocket ship, which spends most of its time in a vacuum environment, a jet engine's useless, so are wings. So it has a chemical rocket engine, and it has thrusters to maneuver in space. And compared to a submarine, which is not a jet or a rocket, because it's underwater, it has a propeller to mechanically displace water, and it uses buoyancy to go up and down. And whenever we try to make a vehicle or something to operate in multiple environments, multiple domains, there's always a design compromise. So let's take a seaplane. A seaplane can fly and it can float, but let's be honest, it's neither a really good plane nor a really good boat. It's a compromise. And yet the things that we're seeing are able to operate in our atmosphere, low Earth atmosphere, high Earth atmosphere, Earth orbit, and seemingly underwater without compromising any of their design characteristics or performance parameters. So that is very significant. And then last but not least, the last observable is what one might call positive lift or anti-gravity. Now, I don't mean anti-gravity in the weird, woo-woo sense. I mean, there's only 3 fundamental ways that we understand how to defy Earth's gravity. The first one is through flight. So you have 4 fundamental forces. You have thrust, lift, drag, and weight. And when you know how to manipulate those, you have flight. You have an airplane. You have wings. Another way to defy Earth's gravity is through sheer ballistics. I can blow something with enough energy out of a tube where it will go up, like think of a mortar, think throwing a baseball, think of an ICBM, where it will go up and then eventually come back down. And then the last way we know how to defy Earth's gravity is through lighter than air. Think of a hot air balloon, think of helium or hydrogen, where the air density inside is less than the air density outside, so it floats. It rises much like oil and water. And yet these things have no wings. They have no obvious signs of propulsion. They don't even look like anything we have, and yet somehow they're able to defy Earth's gravity. And so when you have all of those observables being displayed by a single technology, one begins to realize very quickly that is certainly a paradigm shift to what we're used to dealing with.
Let's say this plane here is an aircraft. An aircraft looks like an aircraft because it has to perform in our atmosphere. So it has a nose, it's got a tail, it's got wings, it's got control surfaces, it's got an engine in the back. So a plane pretty much looks like a plane. Yeah, it might be a B-2 versus an F-16, but it still is a plane. Whereas a rocket doesn't have to fly really for very much time in our atmosphere. It's in no atmosphere. So it has thrusters, doesn't have wings, doesn't have control surfaces, has thrusters, has chemical rocket motors instead of the jet engine, because there's no atmosphere. And yet a submarine looks completely different. It actually uses buoyancy and a propeller to move underwater. And that's why a submarine looks like a submarine, a plane looks like a plane, and a rocket looks like a rocket, for the most part. Yet these things we're seeing can operate in all these environments without changing their physical attributes and still continue to perform the same way. Now, for those of you who are scientists, you know the drag coefficients we're talking about when you're in water. When you look at a torpedo, and I can't go into details here, but anything above a moderate speed underwater, the drag becomes so significant that it's almost impossible to overcome unless you use other technologies to reduce that friction. Okay? And yet these things can perform just as easy. We pick them up on radar, we pick them up on sonar, and we pick them up with everything in between. The next one is hypersonic velocity. So here's our little airplane again flying in the atmosphere. And everybody knows what supersonic speeds are. But when you're talking hypersonic velocity, you're talking about Mach 5 plus. That's really fast, folks. Now, do we have aircraft that can do it? Sure. Heck, the space shuttle did it when it was going achieving orbital velocity. But not the way we're seeing it, and certainly not without the associated signatures. When you see the shuttle launch, baby, you know it's a shuttle. I mean, it's loud. You see a smoke plume for miles and miles and miles. The earth shakes. When an aircraft is doing that kind of speed, or a missile, you have heat ablation and friction. You have atmospheric ionization. You have contrails at the back. You have acoustic signatures, such as sonic booms, that are very hard to get around and engineer around it. Okay? That's why you have something like the B-2. It's really stealthy, but it's not really fast. If you want to be really fast, you're probably not going to be really stealthy. So it's a trade-off. So you have spatial and temporal information all now coming together, telling you that you've got something there. We may not know what it is, it's kind of hard to see it, but maybe the fact that it's hard to see in itself is an observable. Maybe it's telling you something. There's some physics there, right? When you look at the desert, a hot desert, on a hot day, you see that mirage effect. It's kind of hard to see through. Are we looking at something similar? We don't see those compromises when we're looking at the UAP. Why is that? And then, of course, positive lift. The ability to defy the natural effects of Earth's gravitational force. That, by the way, universally applies to us all. Now, do we have technology? Sure. I mean, we have hot air balloons. That's positive lift. We have lift, wings, right? Like an aircraft. You have the four coefficients you have to pay attention to. Thrust, lift, drag, weight. You have a jet engine that can provide that thrust. You have a propeller engine that's kind of a mechanical way of pushing the air, if you will. And then you have rocket engines, chemical engines. But really, those are only the four real ways we know how to defy for any real period of time Earth's natural gravitational force, other than ballistic, right? Like a mortar or just popping a missile out of a silo. Yet these things can fly at these incredible speeds and yet hover like a helicopter. Sometimes for minutes, sometimes for hours, sometimes for days. They can drop in from 80,000 feet down to 50 feet right over the water within less than a couple seconds. 2 seconds.
Could you talk a little bit, Lou, about how like they show up and then they disappear? But you also talked about the fact that it's about the speed, the rate at which they are moving, which may be different than what we're seeing, like as far as time frames are concerned. That's why we think they disappear and show up, but it's actually at the rate in which they're moving that's playing a game with with what we're seeing.
Yeah, so we as human beings live fundamentally in a three-dimensional space that we're all very comfortable with, and there's 3 axes of movement. You have what we call in physics x-axis, y-axis, and z-axis. Or in the vernacular, I can go forward and backwards, left and right, and up and down. And time tends to be the function of a fourth dimension, if you will. And that is the universe in which we are comfortable and that we are used to living. But thanks to the efforts of folks like Einstein, we now realize that space-time, the very fabric of space-time, is indeed flexible. It's malleable. It's not linear in the way that we perceive space-time. And so there is much research going on right now that if you had the ability to just, let's say, temporarily insulate yourself from the effects of Earth's gravity, by definition, you'd have to insulate yourself from all the effects of Earth gravity, not just that sensation of being pulled down to the surface of the Earth, but the warping of space-time that the Earth exhibits on its surrounding. That in itself would be insulated. You would no longer feel the effects of that. And so if you were able to somehow create this bubble around you that insulated yourself from the effects of Earth's natural gravity, then what may appear to an outsider as this incredible rapid movement, almost, if you will, riding the wave tops of space-time, this jerkiness in movement, in fact, really isn't so. If you were inside this bubble looking at the rest of humanity, you might notice us all moving in slow motion, in fact. And so what appears to us as this incredible velocity, hypersonic velocity, instantaneous acceleration, etc., is really just a localized, potentially a localized area of space-time that is insulated from the natural environment around it. And so therefore, you are operating in a different space-time construct, and not even by a lot, even a little bit can really change the perception from the outside. So it may very well be a result of the propulsion being used, potentially the science or the technology that's creating this interesting observation.
You mentioned transmedium as well. I'm curious if you've seen any footage where a UAP goes from air to water, and is there a splash involved? Or do they just submerge as if it's an illusion, let's say, or an artifact of light? Not saying that they are artifacts of light. I'm just curious if they displace the water in any formidable fashion.
Yeah, well, Kurt, there seems to be some sort of interaction. I will state that there's been plenty of reports that we have where the water seems to be perturbed, that there is a disturbance over the water. And there's several hypotheses that have been proposed for that. No different than when you have a helicopter hovering over the water, you can see the water being a bit perturbed from the rotor wash. Yet these don't have rotor wash, but the water seems to be perturbed, roiling, if you will. And we've seen that over and over again, not just with the Nimitz incident. There's some incidents near off the coast of Puerto Rico. There's been some other incidents as well where the reporting by government officials has been that there is some sort of disturbance in the water. The question is, what is causing those disturbances? If you look at biology, for example, look at an alligator, we just now realized over the last maybe decade or two that there are ULFs, ultra low frequencies, acoustic signatures that are emitted by alligators when they are in mating season in the rivers and the lakes. And you can actually see as they put their head up, you can't hear it, but the water begins to what looks like a dance around them. And what's happening is these ultra low frequencies, acoustic frequencies, are perturbing the water, disturbing the water, and the metrics that the matrix of the water is part of. and so it begins to roil. Is this something similar? It could be. We don't know yet because we don't understand the technology fully. But we suspect that this disturbance in the water could be could be a result of the technology being utilized. No different than a helicopter, perhaps, with its rotor wash perturbing the water, but rather than being a physical or mechanical perturbance, it might be due to some sort of electromagnetic interference that's occurring.
Now, let's talk about the fact that this is a transmedium craft. We got space, air, and water. And I've heard an interesting theory, which kind of fits. If this is actually entrapped by what I believe you know as Alcubierre warp bubble, right? If that's the case, then water never touches the craft. Is essentially enveloped in a gravity field. Would you agree with that statement?
Well, I'm not a professional physicist. That's what has been explained to me by government professional physicists. That once the transmedium travel, really, once you have that ability to warp space time in a localized area, all sorts of unique things are now possible.
Gotcha.
That in our current environment, our current paradigm, we simply can't do. So things such as friction coefficients go way down, and it precisely as you're saying, it's possible now to operate through various different domains or environments without the consequences that we have to deal with.
Yeah, you have been talking about the parallel life form I'm talking about. The time bubble theory based on Einstein's work. Now, how did that come about? Is that only based on what has been observed by you now?
No, actually, there was also there was a lot of papers and technical papers done, and there were I remember, I won't say who was there, but we had some scientists I remember specifically sitting in the skiff and having a conversation, and they spent about half an hour writing a mathematical formula that I frankly didn't understand. It took up 3 whiteboards, and at the very end they came to a less than zero function at the end. I said, well, what does that mean? And it said, well, what it means is that if you can do this, then in essence it is the warping of space-time in a localized area that would allow you to achieve all these other observables. So rather than being a separate exotic technology to explain instantaneous acceleration or hypersonic velocity or transmedium travel or all these other things, that if you can do this, if you can bring this equation down to a less than zero, then all this now becomes manifestation of a single technology. It all becomes possible.
So this is the question, are there differences in behavior traits or skill sets depending on the shape of the UAP? For example, is a tic tac different from a disc, or an orb different from a triangle? Or are they maybe all from the same source, or do they seem completely different? Are there differences?
Well, there clearly there are differences, but they may be utilizing the same or similar technologies. And the difference between a disc versus a rod, or if you will, a cigar shaped, and that versus a triangular or even a boomerang, may simply be a result of the propulsion that is being used and the intent and purpose of the vehicle. So, for example, if I wanted a sports car, for example, let's say that the warping of space-time in a localized area is finite. Let's say you have this bubble that can only be so big. Let's just for argument's sake, let's say 43 feet. You can only fit a certain size automobile inside that bubble, a vehicle, right? And so a disc, if you were to have this bubble, right, and you were to take create a car that this bubble is surrounding you on all equal sides, the shape of the car you would want to make sure that you are uniformly fitting inside this bubble is a sphere, because the bubble is a sphere. But a two-dimensional representation is a disc. And if you're driving in a car that's shaped like a disc, and this bubble you want to protect you on all sides equally, a disc would be a perfect way to do that. So think about, let's say, a Corvette. You can fit 2 people in a Corvette, and you can go really fast. But let's say a Corvette isn't big enough. Let's say you need a school bus. you need a lot of people to fit in and a lot of equipment. Well, you could put two of these discs together and have these, if you will, overlapping bubbles. But two discs together is really, you could just draw the line complete. You have now a cigar. That those two discs, you could have a propulsion unit here and a propulsion unit here, and now all of a sudden you've got these two bubbles that are still protecting you equally. Right. And then, of course, there's another shape in geometry that if you needed something really big, really big, like an aircraft carrier, let's say a triangle, right? So you know what? I'll let me show you something real quick. So, let's say this little, I don't know if you can see that here. That is your disc, and you've got this bubble surrounding your disc. Okay. Now, let's say you put another UAP here. Okay. And so now you have these interlocking bubbles. So here is the two, but really those two, what you can do is draw a line between them. And now you have that, right? So now you have this cigar looking vehicle where you have a propulsion unit here on this side and a propulsion unit over here. There's another shape in geometry. Think of a three-legged stool that if I go out 90 degrees from the middle here and I put another propulsion unit here like that, okay, what that is in essence is nothing more than a triangle. Right. And so now you have the propulsion here, you have one here, you have one up
Guys,
here.
do you see that?
And now what you have are, think of a three-legged stool. You have propulsion units providing you equally all over the ship. And that's maybe why these triangles are so big. And that's one of the hypotheses. So
this
the reason
is
why
by far the coolest thing I've heard in weeks.
Well, it's speculation right now, but it seems to be, if you look at the principles of the type of energy needed to create these bubbles, there's an old saying in the Navy, how many nuclear reactors do you put on a ship? Well, the answer is as few as possible, because if something goes wrong with it, the whole thing, your bubble pops.
Yeah, but this makes so much sense. It's like they are able to merge, but also, move separately for certain jobs or something.
Well,
but,
some of the lights that people see, the flashing lights, actually may be a Doppler shift. So if you take this again and you look at that, depending how much, if you will, juice, how strong that bubble is, potentially that will redshift, blue shift light and energy. So what you perceive as a green light or a red light or a yellow light may in fact be a result of those propulsion. If this is the case, if these are propulsion units, what you're seeing is a distortion in that energy, and you're getting these interesting colors going back and forth. And so that may be one of the explanations that people have been throwing around.
Is energy one of the observables, one of the signatures?
Well, energy is fundamentally it's everywhere and it's everything. Matter and energy have a very interesting relationship, and I'm not sure a lot of people really appreciate it. But when you look at the equation E equals mc squared, that really says a lot. And energy and matter on the opposite sides of those equations, they're almost inverses of each other. Meaning, if matter is comprised of energy, just very tightly held packets of energy. So when you take matter and you annihilate it, you get pure energy. And if you take energy and you slow it down, you condense it, you begin to get matter. You start getting these primordial pieces that make up the atom, right? These subatomic pieces. And so think of energy and matter as really the same thing in two different states. Think of ice, a cube of ice, as matter, right? It's hard, you can touch it, you can break it. And think of steam as being energy, right? Highly energetic. They're both water. They're just in different states. And so matter is in a much more condensed state, whereas energy is in a much more active state. And signatures of energy are this entire universe is just one huge signature of energy. And now, of course, we have energy in the absence of energy, right? We have this thing called dark energy that we can't even explain. We can't see it. We can't measure it. And yet many scientists believe it's there. In fact, that's the dominant amount of energy. That's the dominant energy form in the known universe. And so, and yet we can't even interact with it. And so I think it's important to note that whenever we talk about energy, let's look at it from a scientific perspective. What is energy? There's enough energy in my if I were to take a thimble full of me and put it into a thimble full, if I were to convert that into energy instantaneously, it would have the same yield as an atomic bomb. So we are all walking packets of energy. There's no way around it. So when we say we're looking for signatures of energy, yes, almost by definition, anything and everything in our universe is energy. It's just in a various state of energy.
There are a lot of cases either above, near, or under, even under the water of these UAP. Why? What's water? What are some of what's a theory regarding UAP and water and their relationship to water?
Well, I would defer to some of my colleagues who are qualified to talk about physics, but it's been proposed that without going into a whole lot of detail, water may be some sort of simplistic fuel source. When you look at what water is comprised of, primarily hydrogen and oxygen, if you wanted to get a yield of energy, cracking the atom is one way to do it. And the smaller you go into the world of the atom, the more tightly that energy is packaged within the atom and subatomic particles of an atom. And so if you want to warp space-time, some have theorized that you need a lot of energy. There's two ways to warp space-time: a lot of mass or a lot of energy. And it turns out that you need a lot of energy to do it. And if one wanted to harness that energy, perhaps one of the most efficient ways is through hydrogen. Now, of course, I could go out, I guess, in outer space and mine it in a nebula, but out in space, it's not dense. It may take you a very long time to do that. Whereas here on Earth, hydrogen, when it's connected with oxygen, it becomes extremely dense. You have this thing called water, H2O, where you have an abundant amount of hydrogen, more hydrogen than you know what to do with. That would be very easy to mine. So that's one speculation that's been offered.
Okay, Rayson Carlos asks, could you ask him about the Nimitz case? David Fravers said that the tic-tac-shaped UFO, after disappearing from his view, appeared to the radar operator at his quote-unquote cap point. What does this represent? How on earth did the UFO know the cap point beforehand?
Great question. We don't know how it knew. Either that or it's one hell of a coincidence. A cap point is a rendezvous point that is input into the flight plan of the pilots and the avionics systems of the aircraft. In this case, it was about 60 miles away from their location where they encountered the tic-tac, and within 5 seconds, this thing appeared over their cap point, seemingly anticipating where they were supposed to go and waiting for them. Great question. Is this some sort of active exploitation of the avionics? Or is this some sort of predetermination, understanding where the plane was going to go because somehow it understands space-time in a different way than we do? Or was it just a pure coincidence? We simply don't know. Yeah, absolutely. And so, I think there's two congruencies that we see. We see an interest in our nuclear capabilities, and then we have this really bizarre I don't know if you'd call it an interest, but there seems to be a connection with water. And these things have a tendency to be seen in and around water, which kind of leads to one of the observables that we've had. There's 5 distinct observables that set this technology, as I mentioned earlier, aside from everything we have in our inventory. The first is hypersonic velocity, the ability to change directions instantly. And when I say instantly, I mean human beings can withstand about 9 G forces. Some of our best aircraft can withstand about 16 Gs. These things are doing 300, 400, 600 Gs in mid-flight. Then there's hypersonic velocity. That is speeds that by definition are Mach 5 or above, very, very fast. We do have some technology. You mentioned Russian hypersonics and things like that. There are technologies that can go that fast. But then again, you don't expect a hypersonic aircraft to do a 90-degree turn. To put that into context, our SR-71 Blackbird, when at 3,200 miles an hour, wants to take a right-hand turn, it takes roughly half the state of Ohio to do it. You don't expect it to just kind of do this. And that's precisely what we're seeing. And then the third observable is a bit like cloaking. We call it low observability. But the fourth observable is what we were talking about, and that's transmedium travel and water. The ability for an object to fly not only in our atmosphere, low and high altitudes, but also potentially in a vacuum environment like space and even underwater. Now, we do have vehicles that can do that. We have, for example, a seaplane. A seaplane is a plane that can fly and it can float on the water. But when you look at it, it's neither really a very good aircraft or a boat because it's a design compromise. And yet what we are seeing are objects that can operate in all these domains or all these environments, seemingly without any type of performance compromise. And so why are we seeing these things around in and around water is something that we're really kind of scratching our heads with, because we've seen these things. They've been recorded not only in our atmosphere, but there is data to suggest that they have also been tracked by some of our capabilities underwater as well, and being able to perform in ways that frankly exceed anything that we know on the planet right now.
So water is energy. You know, there's a lot of energy in water. Do you think these UAPs who just go under, there was some point you were saying it might be a fueling thing or a source of energy for the UAPs.
So let's exactly. So let's go back to this drawing here, right? These energy, these let's call them, if you want, propulsion units or whatever. If this is the way it goes, there's two ways to warp space-time that we know of. The first one is with a lot of matter, a lot of mass, right? Like the mass of Earth is perturbing space-time around it. The mass of Jupiter perturbs space-time even more, and the mass of the sun even more, right? Until eventually you have something like a black hole where space-time almost becomes nonsensical. All matter distorts space-time, but so does energy. It just turns out you need a lot more of that energy to warp space-time. So let's go back to our analogy of ice cube and steam. If I take a bed sheet, let's say that's space-time, perfectly flat, no distortions, and I put an ice cube right in the middle of the bed, I'm going to get some wrinkles right around the bed sheet, and that is the warping of space-time in that localized area. That's a kind of a crude way of looking at it. Well, if I wanted to create that same level of distortion, I would need a steam gun, right, to shoot it down at the bed with a lot more steam to create that same effect. Well, you need a lot of energy to warp space-time, and you need a lot of it. And so there is a discussion that if you wanted to create that level of energy, to create that yield, you would need an energy source. And one of the simplest and most, if you will, abundant elements in the known universe is hydrogen. And hydrogen, if I wanted to break apart, so that when you go from, we're going to get to a physics lesson here, and I'm not a physicist. When you go from big to small, if I take a glass of water and I convert it to steam, that's a 1 × 10 to the third yield, energy yield. And it took Archimedes with his steam engine to figure it out. And we have locomotives in the 1800s that we use. It wasn't until the 11th century and the Chinese who invented gunpowder, and that was breaking down matter even further to the molecular, breaking apart the molecular bonds, and there was an exothermic release of energy, and that's a 1 × 10 to the 4th yield of energy.
Right.
Turns out, of course, last century we figured about the secrets of the atom, and once we learned how to split apart an atom, that was through fission. That was a 1 × 10 to the 5th yield, or what we express as a kiloton yield of energy release. And then we have a nuclear bomb, right, really big, and then you get into nuclear. Now you start breaking up the nucleus of an atom, and you have a 1 × 10 to the 6th yield, which is known as a megaton example of yield of energy. And so forth and so forth. And so the smaller you go down in matter, the more energy is tightly held together. But when it's released, it's exponential. And so it's quite possible that we're seeing the same thing here, that these UAP are mining hydrogen,
and not
Right.
in a nebulous cloud, but in water, because water, it's the only place in the universe where you can mine hydrogen in the density that it's in, because it's locked into that oxygen. It is extremely abundant. You don't have to spend 100 years mining a gas nebula. You have all the hydrogen you could possibly need with one bucket full of water, let's say, in the ocean, right? So it could very well be that has been speculated that the oceans are some sort of fuel supply because of the abundance of hydrogen.